You ever been walking against a really strong wind and felt that invisible push? Or maybe you felt that unseen pull when you're cycling downhill, no hands. Well, those are forces, and they are acting on us literally all the time. So today, we're going to break down what's really going on, all by following a simple story. Our story kicks off with two friends, Sonali and Ragini, who just wanted to go for a bike ride. But it ended up being a real science lesson in disguise. So picture this. It's a pretty windy day, but they're excited. They set off to explore the countryside. Everything seems perfect, but that wind is going to be a bigger deal than they think. And there it is. As they're riding along, Ragini starts to really struggle. She can feel this powerful push from the wind, making her pedals so much harder just to move. Now, this isn't just a feeling she's having, it's actually our first big clue to understanding what a force really is. The ride brings up some classic questions we've all wondered about. Like, why does it take so much more effort to go uphill? And what is that awesome, effortless feeling of being pulled down a slope? What's really going on there? This is the mystery we're about to solve. So, how do we explain all these things that Sonali and Ragini were feeling on their ride? Well, it all comes down to one simple but really powerful idea. And here it is. In science, a force is simply a push or a pull. That's it. The wind pushing against Ragini, her feet pushing down on the pedals, these are all forces in action. It really is that simple. Every single force you can think of boils down to one of these two things. You're either pushing something away from you or you're pulling it closer. Just think about your day so far. Every door you opened, every step you took, it was a push or a pull. And of course, scientists need a way to measure all this pushing and pulling. So the standard unit of force is called the Newton, named after the one and only Sir Isaac Newton. We just write it as a capital N. And if you're wondering what 1 Newton of force feels like, it's about the same force you'd need to lift a small apple. Okay, so we know what a force is, but what can it actually do? Well, the effects of a force are what we see and feel all around us, every single day. A single push or a pull can do some pretty incredible things, right? It can get something that's sitting still to start moving. It can speed a moving thing up or slow it way down. It can totally change its direction, or it can even change an object's actual shape. Let's look at some examples. Here's a perfect example. You've got a cricket ball just rocketing through the air. When the fielder catches it, their hand applies a force that completely changes its speed. Bam! It comes to a dead stop. And here's a much simpler one from everyday life. A drawer is just sitting there, not moving. You apply a pull force with your hand, and suddenly, it's in motion. That is the very first effect we talked about, making an object move from rest. And what about changing shape? Easy. When you pull on both ends of a rubber band, you're applying a force, and you can see the result right away as the band stretches and completely changes its form. All right, let's get a little more specific now. See, not all forces are the same. We're going to zoom in on a category of forces that require things to actually touch. These are called contact forces. The definition is pretty much right there in the name, right? For a contact force to happen, two objects have to be physically touching, pushing or pulling directly on each other. Like your hand pushing a door open or your foot kicking a soccer ball. So one of the most common contact forces we ever experience is muscular force. This is the force that's generated by the action of muscles, both in our bodies and in the bodies of animals too. So whether it's the force from your own leg muscles pushing you up a flight of stairs, or the incredible power of an ox's muscles pulling a plow through a field, this type of force is absolutely essential for getting things done. But here's the really cool part. Muscular force isn't just for walking or lifting things. It's happening inside you right now. The muscles in your stomach are contracting to push food through your system, and your heart, which is a super powerful muscle, is pumping blood all throughout your body. Okay, time for another big question. Think about this. If you roll a ball across the floor, it doesn't keep rolling forever, right? It slows down, and eventually it stops. But if no one is pushing it to stop it, what's going on? The answer is friction. Friction is another one of those contact forces, and its whole job is to oppose motion between two surfaces that are touching. You could almost think of it as the universe's natural brake pedal. And this takes us right back to our story. Remember when Sonali and Ragini hit those rough patches of road and it got really hard to pedal? That was friction. The rough surface created more friction with their tires, pushing back against them and making them work way harder to move forward. So, as we've seen from just a simple bike ride, forces are kind of like the invisible architects of everything that moves and interacts in our world. Let's put all these pieces together. Think about it, from the muscular force pushing those pedals to the invisible pull that helped them coast down the hill, to the friction from the road and the wind pushing against them, every single moment of their journey was just a dance of different forces. So, I'll leave you with this thought. Right now, at this very moment, what forces are at play on you? There's definitely a pull holding you in your chair and a push from the floor against your feet. Once you start looking for them, you'll realize they are absolutely everywhere.